Welcome to my classroom. This is Justine. Today I am going to discuss about basic classification of statistics. One is inferential statistics, other one is descriptive statistics. So these are the basic classification. So we all might have heard about this descriptive statistics and inferential statistics. Let us have a look at it. Descriptive statistics, as the name indicates, any statistics which are used to describe the sample. For example, let us say my sample has 8 male and 9 females. I am describing my sample. What is the method I have used? Frequency distribution. I just described my sample, or I can present in a percentage way. Let us say around 50% of my male sample are male. That's another way in which I can present my sample. I'm presenting it with a frequency distribution and a percentage scores. So frequency distribution or percentage score, these two are simple descriptive statistics. What are the other ways in which we describe our sample? For example, let us say the average age of my sample. Usually this we write this in our articles. Every journal, when we describe our sample, we used to write this particular score. So let us say 26.5 is the average age of my sample. What is this? Very simple. This is a measure of central tendency, that is average. Most probably this could be arithmetic mean. I am describing my sample. Or I'll say that my sample age ranging from 19 to 29. What is that? It's a higher score, it's a lower score. It's a kind of measure of range. So these are the different ways in which generally we describe our sample. So any statistical method used to describe our sample are called as descriptive statistics. So what are the major classification here? So one is the frequency distribution, other one is the percentage, and other one is measure of central tendency. Measures of central tendency. What are the measures of central tendency? That is mean, then median, and mode. And other set is measure of dispersion. What are the measures of dispersion? One is range. Then we have quartile deviation, we have standard deviation, or we use mean deviation, like that. So these are the different measures of dispersion. These are the measures of central tendency and frequency, percentage. These are the major ways in which we describe our sample. So this is descriptive statistics. So let us go to what is measure of central tendency means and what is a measure of dispersion indicates. So the first one is measure of central tendency. So as the name indicates, central tendency, something fall in the central tendency, and that would be a kind of average. So if you think about any data which is kind of normally distributed, I have done a video on what is normal distribution, a data which is kind of normal distributed, and if you think about the center point, most probably that would be the average line. So that is a value that can be used to represent a sample. For example, I have conducted an exam and the scores of the marks of the students are 1, 2, 3, 4, 5. So any value that represent a better value that can represent all the scores could be 3. So what I do, I will add all the scores. Let us say 1 plus 2 plus 3 plus 4 plus 5 divided by how many scores are here? 5. So this is a first measure of central tendency, that is arithmetic mean. Generally we call it mean. Actually it has to be arithmetic mean, but generally we call it mean. So you get a score of 3. Yeah, this is most frequently used measure of central tendency. This is I would say it's a most sophisticated method to understand the central tendency, because this measure of central tendency is based on all the values. Each value is taken into consideration. Okay, so this is a measure of the most important measure of central tendency, arithmetic mean. And what if some of the values are different? For example, instead of 5, I have a score of 100. So what happens? In general, arithmetic mean from the center point 3 move towards 22 nearby 22. If you add all the scores, divide by 5, you get a score nearby 22. Now, think about it, whether this value 22 is representing any of the scores here. When you had a score of 3, it was a kind of representing almost 1, 2, 3, 4 and 5, kind of nearby value. Now, this is another value 22 which is not representing any of the scores. So what happened here? We had an extreme score, see that, an extreme score 100, and which has pulled the value, the center point towards the extreme score. Now I cannot trust the arithmetic mean here. So what else I have to do? I have to look for another kind of measure of central tendency. That would be median. So what is median? The value which is at the center of the score. So for example, I have 5 values here, 1, 2, 3, 4, 5, and the center position irrespective of the scores is 3. 1, 2, 3, 4, 5 values are here, and the center position is 3. So this is a positional average. See that term? Positional average. So this is called as median. So median would be 3. Now the difference between mean and median, or in terms of application, if your scores are normally distributed or if your scores doesn't have any kind of extreme values, then arithmetic mean would be a good one. And if your scores are some kind of extreme values, you can think about median. See that? Median, that is not much influenced by the extreme values. So that's the benefit of using median than mean. But the problem is median is not based on all the scores. It is just the positional value. That is irrespective of all other scores. If the centermost position is let us say 50, then 50 will be the score there. Yeah, that's a problem with the median. And the third method is mode. Mode is a basically used when you have kind of categorical data. You generally call it nominal data. There's the levels of measurement. I have done a video on this one. Nominal, ordinal, equilateral ratio. That nominal data, that kind of data we use mode. For example, in my sample I have male, female, transgender, and male I have 15 members, female I have 75 members, transgender I have 5 members. Now look at the sample. I would say mode of my sample, sex of my sample is female, like this. So any value, any statistical method to represent the sample, right? So I am representing my sample, a score which can be used to describe my sample. But generally we don't use mode in this line. So what we generally use in this context is frequency itself. Either frequency, that is the value, or the percentage value. This is how generally we use. Mode is, this is the place where we are supposed to use mode, but generally mode is not required to use in this context. So these are the measure of central tendency. So why should we use the measure of central tendency, measure of dispersion along with the measure of central tendency? So I made an argument now itself that whenever you use measure of central tendency, you are expected to use measures of dispersion. Why? For example, let us take a data. So I have score 1, 2, 3. Okay, this is a class A, and the scores are 1, 2, 3. What's the average of this data? That is 2. And I have another class B, the scores are 0, 2, 4. What's the average of this data? Again 2. I have another score 3, another class 3, and the marks of the students are -1. -1 cannot be marked, but just take a score like that. -1, 2 and 5. What's the average? Again 2. Another class, one more class, D, -2, 2 and 6. What's an average? Again 2. So what happens? What generally happened in this context? So the every class A, B, C, D, the average score is 2. What if somebody don't look into the score like this and take the average value? So somebody want to compare how is the performance of class A, B, C, D. So if you look at the average score, they'll say, oh, they are all same, but they are not same. The scores are, mean scores are same, but inside the data scores are different. So how do you understand? So what happened in this data? What's the difference in each data? Mean is same. What's the differences in each data? So the characteristics, the range of the data. See that? Data is not scattered much here. data is more scattered here. Data is much more scattered here. Data is much more scattered from the center here. See this? So whenever you present this average, you are expected to say that how much data is scattered, so that the person who read the mean value get a very clear-cut kind of idea that even though this is a center point, how much data is scattered. So any measure to talk about this concept is called as measure of dispersion. What is a common measure of dispersion that we use? Generally, as we said, the scores are ranging from average age of the sample is ranging from 15 to 21 years. So this is the highest score, this is the lowest score. So H minus L. So this is range or quartile deviation. Quartile deviation is when you have a set of data, let us say a set of data, I divide the entire data to 4 parts. Let us say one set here, one set here, one set here. This is Q1 and this is Q2 and this is Q3. So I divided the entire data to 3 parts, Q1, Q2 and Q3. So this is first part, second part, third part, fourth part. These points are Q1, Q2, Q3. So this is called a quartiles. So what I do is I'll take the Q3, that is Q3 minus Q1 divided by 2. What does it mean? Q3 minus Q1, this is the entire space, this place to this much space, and average of it. I mean, that means half of it. It's a way to understand how much data is scattered. So why do we use this particular method? Just because what if you have a lot of extreme data? So this area can be ignored because there would be some extreme data. This area can be ignored, there would be some extreme data. So I will be discussing this in detail when I talk about what is quartile deviation or manual calculation of quartile deviation. Other method is standard deviation. So what is standard deviation? How much data is deviated from the center? What center point? That is the value that is arithmetic mean. For example, you have a score like 1, 2, 3, 4, 5, average is 3. So what I do is how much each data is deviated from the center, that is x bar. Center is 3, 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, like that. And I'll try to understand what's the average of changes in the data. So this is standard deviation. Or mean deviation also work in the same line. So these are the measures of central tendency and measures of dispersion. So together we can consider this frequency, percentage analysis and descriptive statistics as descriptive statistics along with the measures of central tendency and measure of dispersion. So what is inferential statistics now? So any statistical method used to make inferences from the data, or I will say in another way, like any statistical method that are used to confirm the inferences that we make out of descriptive statistics. For example, average marks of my sample is, let us say, average mark of class A is 45. Average mark of class B is 47.5. Let us say these are the scores. Now, what's the inference that you can make from this? I can say that A is or B is better than A. Now, this can be the inference that I can make out of this data. Or can you really make a data inference like that by looking at the data? 47.5 is better than 45, obviously higher score than that one. Or is it a significant difference? Or can you really make an argument like that or an inference like that? Class B is better than class A. Or is it a negligible kind of score? What if the scores were like this? 45 was a score and one group score and another group is 45.1. Would you say that this group, let's say A and B, in this condition B is better than A? Or is this a negligible difference? 0.1, the difference is negligible difference. Here the difference is 2.5. Here the difference is 0.5, 0.1. Now how do you make a conclusion here? Or what if it is 0.2? Then does it mean that this group B, I mean class B is better than class A? Or what's the cutoff? How do you know that how much differences has to be there to say two groups are different? So any statistical method used to make that particular decision whether the difference between two groups are significant enough. Suppose you get a kind of result, a kind of strong, any kind of statistical result which says that, see, this 2.5 is a significant difference, or this 0.1 is not a significant difference, then you can very confidently say that, see, in this condition class B is better than class A, or in this condition class A is equal to class B, this difference is not a significant difference. I remember once one of my students asked me like this, see, there's a difference, 2.5 is bigger, there's a 47.5 is bigger than 45. Now why don't you think that this 2.5 can be neglected? So the answer to that particular question is, there could be always a sampling fluctuation, changes in the data, random changes in the data. We'll plan a data now, then we'll explain the concept of sampling fluctuation, which can happen when you take a kind of data. For that, I'm going to take an example of price of two products, let us say apple and orange, then we'll compare that. Okay, our data is ready. So I have January to December, a year, consider that as my population, and I have two products here, orange and grapes, and the price of this thing, imaginary price of these two fruits are written here. So this is my population, and I am going to take a sample from this. Let us say I am going to take a sample like this. Now my question is, which product is more costly, which fruit is more costly? So if I find out average of orange, so orange of the sample, sample, orange will be 47.5 if you take the average of this data, or grapes average will be 45. Now what's the conclusion that you have? Can we say that orange is more costly than the grapes? Can we say a conclusion like that based on the sample? Because how do you do a research? From the population, you take a small sample, and assuming that would be representing the population, you may use a proper sampling method, something like a probability random sampling or probability sampling methods, and you try to make a conclusion and you try to generalize that result to the entire population. So can I make a conclusion like orange is more costly than grapes in the entire year, which is my population? Can we do that one? You cannot. For example, let us say, what if you calculate the entire population average? This will be 42.92, and this score, if you calculate, that also will be 42.92. See this? These are same. Two scores are same. If you take the entire year, entire population, the average cost of the price of orange and average price of the grapes, both are the same. Now how did we get the result like this, orange and grape? A difference like 2.5, a difference here. This is called a sampling fluctuation. I have taken a sample where orange were more costly at time April, May, June, July. Orange price was higher compared to the other particular product. And this differences from the entire population, the differences in the sample that we take, these differences are called a sampling fluctuation. What if you take another sample somewhere here? You will get a different kind of result. That means whatever may be the population, if you take different kind of sample, there will be a small difference. Same population itself, let us say same population, I take 5 members, and that will give me a kind of mean, and another another group where I take another group that I take from the population, and that will give me a similar kind of mean. For example, I may get a first mean would be 45.2, I may get the next sample when I take it would be 45.3, like this. See that? So this kind of small differences could be there. So these changes are sampling fluctuations, changes due to sampling fluctuations. So generally we need to consider this as a insignificant difference. So we need any statistical method to see whether this difference is an insignificant difference or not, or a significant difference. I may do a t-test, independent sample t-test, to compare these two groups and see whether the difference 2.5 is a significant or insignificant difference. Okay, so what is a sampling fluctuation actually? It's an indication of sampling. It's called a sampling error or sampling fluctuation, specific terms like that. So every time when you compare the sample with the population, there would be small difference, could be a big difference or small difference. So this is your population, and assume that this is your sample, and the average sample would be like, score will be somewhere here. The gap in between these two, see this, the sample is not representing this area. So the difference between your sample and your population, this is called as sampling error or standard error. Standard error is a statistical application or statistical description of the sampling error. So standard error or sampling error. So when the sampling the standard error or sampling error is very less, that indicates that your sample is perfectly explaining your population. There is a good representation. The scores are almost the same. A good representation is there. For that, what you really need to do is increase the sample size. When you increase the sample size, generally the sample will be representing entire area. So any statistical method to make the conclusion that or test the inference that orange is better than grape, or any two groups are different or not different, that is making an inference. Basically, these inferences are made from the descriptive stats in general. Inferences are made from a descriptive statistics itself. So these methods are called inferential statistics. There are a huge number of inferential statistics. Okay, so one of the common way in which we do inferential statistics is significance testing, null hypothesis testing. So what we do under this let us say in significance testing, null hypothesis testing, we have t-test, ANOVA, or non-parametric or parametric test. In the t-test and ANOVA are parametric test. You have non-parametric tests like Mann-Whitney U-test, or other methods like regression analysis, or you have another set like Kruskal values, like that. Different set of analysis are there. Correlation, that's can be considered inferential statistics. For example, you have a correlation value like R equal to correlation, Carl Pearson product moment correlation coefficient, R equal to 0.5. Now my question is whether this 0.5 is a significant correlation or not. So I'll be testing whether this is a significantly different from 0. So I will say that yeah, it is significant correlation. We'll be discussing what is the significance exactly mean, but this are called as inferential statistics. So this is a basic classification: descriptive statistics and inferential statistics. So I will be uploading some more videos which explain in detail in each descriptive and inferential statistics. Bye for now.